In this section, we're going to cover inverse functions. So the inverse sine function. What is an inverse function? You're probably wondering at this point. So an inverse function, what it does is it reverses what the original function does. We did a lot of this in Math 111. So you've seen some examples before where we had if y equaled x squared, the opposite of squaring would be square rooting. So those would be inverse functions. The inverse of a logarithm function is an exponential function, so it's undoing. So therefore, an inverse sine function would allow us to undo the sine function to determine what angle or input would yield a specific sine value. Specifically, instead of asking the sine of 30 degrees equals what, instead, the input value is going to become, or instead we'd ask the sine of what equals 1/2. But can the sine function have an inverse function? The answer is yes, but remember we learned about inverse functions. Those only work if they're one-to-one functions. So one-to-one means it can pass the horizontal line test. If I look at the sine function, it doesn't. There's lots of repeats. So for example, if I asked you to tell me what is the sine of what equals 1/2. So again, I'm doing an inverse now. So instead of inputting in the 30 degrees and asking what is the output, I'm giving you the output and I'm asking you to find the input. Well, there's a ton that give you 30 degrees. So, or sorry, that give you 1/2. So we know that 30 degrees does, or pi over 6 is another way to write that. We know that we've got 1/2 again, so 1/2 would be right here. So it happened here at pi over 6. It happens again right here, it's 1/2. Right here, it's 1/2. Right here, it's 1/2. So how do we know which angle to put in there? So what we do for the sine function when we're finding the sine inverse is what we do is it's called restricting it. So we're going to restrict it. So it's only going to be those values between negative pi over 2 and pi over 2. So that way, oops, the negative pi over 2 is right here. So just this portion of it. It's going to hit every value. So again, if I said the sine of what is 1/2, now in that blue part, you only have one solution to that. So we know what that answer should be. So the inverse of the sine function, and you're going to see it written as sine to the -1 power, but you don't say it that way. Instead, you say sine inverse. That's what that -1 means. We learned that again in Math 111. So the inverse sine function is sometimes called the arc sine, which is notated like this. In this class, we're going to be using this notation, but just in case you ever see arc sine and sine to the -1 power, which is not to the -1 power, but the notation means is the they both mean the same thing. So and then for us to know, so again, to get it so that this was a one-to-one function, the domain of that sine inverse function is going to be between, so we're going to use this, we're going to restrict the sine to just being here. Now remember, sine inverses, now the x values become the y values. So if I'm looking right here, the domain is going to become the y value, so between -1 and 1. And then the range is going to be those x values, so between negative pi over 2 and pi over 2. So we have to restrict that domain just so that we know if I say the sine of what equals 1/2, you have just one solution, so it's 1-to-1. And again, just remembering this does not mean to the -1 power, even though I've been saying that. It means that is a notation. So for example, if we had to use a calculator to find 5 pi over 12, so what you can do is you could go to Desmos or you could use your regular calculator, make sure that the mode that's used there, so you would go to Desmos and then click on the scientific calculator. So make sure that mode that's in there is in terms of radians, because this is in terms of a radian. So if you used a calculator and you found the sine of 5 pi over 12, you would find that that equals 0.97. So based on that answer, we could say the sine inverse of 0.97 is 5 pi over 12. So again, the sine inverse switches this. So this is saying, the other word of looking at this is, here's your output. So what angle gives you this value? Okay, so now if we were asked to find the sine inverse of 1/2, so this is basically saying what angle gives us 1/2 as the output. So looking at our unit circle, and again, we're restricted to being only between negative pi over 2 and pi over 2, so we're restricted to right here. Looking at those y values, because that's the sine, that we only have that output in one spot between negative pi over 2 and pi over 2, and that's at 30 degrees or pi over 6. If we were asked to evaluate the sine inverse of negative root 2 over 2, so again, it's sine inverse, so we're restricted to just this part. So now this is saying the sine is negative root 2 over 2. What angle gives us that? So negative root 2 over 2 is here. The angle that gave us that was 7 pi over 4. So this is just reversing it. However, I can't call it 7 pi over 4 because that is not in the domain. Remember, we said, or in the range, we said that the range is between negative pi over 2 and pi over 2. So I need to find an equivalent to 7 pi over 4. Well, 7 pi over 4 is right here. So I could write that as a negative angle as negative pi over 4. So taking 2 pi, subtracting pi over 4 from that would put us right to this 7 pi over 4. So we're going to have to sometimes find equivalent angles.